So today we're going to make something really cool and really fun. Have you ever had a lava lamp? I have. But have you ever made one? I haven't. Let's do it. And we're not even going to use heat or lava, so there's no need for any safety equipment for this experiment. You'll want a clear bottle and we're going to put some oil in it. Just some vegetable oil. And now I have some water. I put some food coloring in it just so you can see the difference between the yellow oil and the bluish water. Now make sure you watch very carefully what happens when I pour in this water. That's weird. So even though I poured in the water on top of the oil, the water still sat at the bottom. So do you know why this happens? Well, we've learned that water is made up of oxygen and hydrogen. Well, oil is made out of carbon and hydrogen. Which one do you think is heavier, carbon or oxygen? It's oxygen. That makes water heavier than oil. So the same amount of water is heavier than the same amount of oil. And this is what makes water more dense than oil, making it sit at the bottom of the bottle. But there's a second reason that water is more dense than oil. Do you know what it is? Do you know the definition of dense? It just means that it's packed tightly together. The more dense something is, the more tightly it's packed. Do you remember our experiment where we had water travel down the string? We talked about water's cohesive property, meaning it sticks to itself. Water molecules are very attracted to each other, like a magnet, and they'll stick very close together. But oil molecules are only slightly attracted to each other and will only slightly pack together. So this makes water more dense than oil, again, because it's more packed. So first is because oxygen is heavier, the water is heavier, but also because water is so packed, the water is more dense, and again sits at the bottom. Even if you shake the jar, the oil and the water mix together. But as it settles, the oil and water will separate because the water molecules are attracting the other water molecules, and the oil molecules are attracting all the other oil molecules. Now, let's get back to the lava lamp. We're going to add a little bit more oil. And now we add an acid tablet. I'm sure your parents have one lying around. Then we just sit back and watch. As you watch, I want you to think back to our volcano experiment and our elephant toothpaste experiment. Do you remember what caused the eruptions? It was gas bubbles forming and rising to the top and exploding out. Well, that's exactly what's happening here. Gas bubbles form from the tablet in the water, and these gas bubbles float to the top, and when they pop, the water pushes its way back to the bottom. And that's how a lava lamp works. So what did we learn today? Other than making our very own lava lamp, we also learned that different liquids have different densities and how they will always fight to try to stay together. Well, you could say the same for people of different religions and different backgrounds. Especially here in America, we are surrounded by people of different religions and different backgrounds. And it's okay to get mixed in. Just shake up the bottle a little bit. Mix up that oil and water. Mix up those different religions and backgrounds and different views. When the water floated to the top inside those little gas bubbles, when it popped, the water always fought its way back down where it belongs. So don't be afraid. Be open and be accepting of other people and their different views. Because you too will always have a place to come back to, where you belong, your faith. So go out and have fun and learn and accept new people, and until next time, bye!